Hi, folks. Welcome, everyone, to this webinar. We're going to get started in about a minute as we still have people joining us.
I'm really looking forward to this topic, since there's so many engineering managers who are, looking at how do we include the AI in TDD and what will it mean for development teams.
This is the hot topic of the quarter.
Yeah.
Everyone, yes. So to the question, will that be recorded? Yes, it will be recorded. So you will have the opportunity to watch it again and share it with your team. All right, 30 more seconds and we'll get started. All right, so welcome again to this webinar. Happy Wednesday to our audience. I'm Laurent Py, the CEO of Packmind. And for those of you who don't know yet Packmind, this is the assistant of tech leads, enabling them to accelerate developer skill growth by sharing best practices. With our Rich ID and code review plugin ecosystem, Packmind brings these best practices that are contextualized to the project directly to developers, exactly where and when they need it. So if you want to know more and you don't know yet the solution, feel free to check out Packmind, packmind.com. So today is our webinar number 7 of the year. So we run bi-weekly webinars on tech leadership and technical topics. This quarter, as we were just discussing with Valentina, we focus on how AI is transforming and impacting the developer's job. And today we will talk and focus on TDD, and more specifically AI in TDD, with our exceptional guest, Valentina Jemuović, renowned coach and tech lead. So Valentina, welcome. I know our audience is really excited to know more about how AI is transforming TDD. So the floor is yours.
Great. So I'll get started. So yes, as mentioned, today we'll be talking about AI in TDD. And just a short introduction about myself. I'm a technical coach and I focus on test-driven development, hexagonal and clean architecture. And I help teams to increase quality and accelerate delivery. So feel free to follow me and connect on social media. As for today, so we will firstly have a very short overview of the TDD cycle. Then we'll have a discussion about AI in TDD. So to discover, what are its strengths and weaknesses. And then we'll also have a practical coding demo using Copilot, whereby I essentially had a user story with some acceptance criteria, and then was using Copilot to implement that user story with test-driven development. And let's find out, how did it go? Where did it work well and what didn't go well? And this is very useful so that you can know, where and where not to apply it in your teams. So first of all, overview of the TDD cycle. So the TDD cycle starts with red, write a failing test, and that represents the specifications. So this means if we had a user story with some acceptance criteria, we would write a failing test deriving from the acceptance criteria. And that represents the specifications which aren't yet satisfied by the source code. Then we have the green step, which means writing some code to make the test pass. So that means making the code behave in accordance with the specifications. and the test is passing. And finally, we also have opportunity to refactor. So if we find ways to make the code cleaner, we can refactor the code and rerun the test again to make sure that we didn't break anything regarding refactoring. So now we come to discussing AI in TDD. So what are the ways that we can use AI within the TDD cycle?
Yeah, and just before we go through the list of questions, I wanted to share, Valentina, a few data points with our audience. Beyond the KPIs that have been shared by GitHub about Copilot, 55% faster coding. There are research that have been done by a few players like GitClear that have showed some red flag when it comes to code quality in the repository where AI assistants were used. So amongst these, let's say, red flagged, there was the decrease in code refactored by 70%. There was also the increase in copy-paste by 11%, so like almost a junior developer would do. And something that is even more concerning to me, the increase by almost 40% in terms of code share. So the key takeaways is that when teams use Code AI Assistant, developers need to be really thoughtful about them. It's not the source of truth, and yeah, that's really that can be really dangerous if you don't think critically when using them. So we're gonna see through a list of questions and you live example how AI can really help in TDD. Before we go through the questions, I'm really curious to know more about our audience and who is using today TDD on their project. So we have a quick poll for you. Just gonna give a few more seconds for people to answer. And you will see, Valentina, if you have TDD experts in the room.
It's great to have a balanced audience.
Yeah. So let's see the results now. Yeah, it's 50%, almost half doing it. Occasionally, and 43% doing it every week. So I think we have audience really aware about TDD. All right. So next question is: when it comes to AI and AI assistant, are you using today a solution like could be Copilot, Codium, GitLab Duo, another one, or no? Ooh, we have a clear winner. Yeah, and we have a clear winner, ChatGPT and GitHub Copilot, and I think that really align with some of the market surveys we've seen. Microsoft is the dominant player there.
Yeah.
All right, so we can move to. Thank you for the answer. I think we are right to the topic, folks. Practicing TDD on a regular basis and also using AI. So let's see if what you uncovered really resonate with their own learnings. So to start with the first question to you, Valentina. When it comes to understand, the user story, the requirement, and translate it into a test, how do you see AI, could be, again, Copilot, ChatGPT, or others, helping there?
Mm-hmm. So the first challenge that I see there, and the question I ask is, can even humans correctly translate requirements into tests? So often to actually do translation into test, it often involves also questioning the requirements. For example, are the requirements even consistent? Are they logical? Do they make sense? Are they testable? And that requires a lot of back and forth communication, for example, with developers, product owner, domain experts. Now, this is where I find AI currently to be on the more passive form. So given some task, it attempts to do the best attempt, whatever it's given, such as it is able to, given a user story and acceptance criteria, yes, it is able to produce some tests, but it is not able to, it does not question the requirements. So this is where essentially there's a possible gap. So I would say it may translate the requirements, but there could be issues in the translation itself, or its inability to detect problems in the requirements themselves. And this, to be honest, is what I view as one of the highest cognitive activities, and one where I see humans as having the highest strong points. And this is the one where I think if AI will take over anything, like this is the last thing that I would put on the list in terms of AI taking over.
Yeah, that's the critical thinking is the most important part of the testing activity, challenging the requirements, and that's not where AI is good at. I would add yet.
Correct. Because that's the one where even humans struggle. And the other interesting thing that happens when we apply TDD, when we try to write the test, if we find out it's not clear to us to write the test, that's the moment that we would ask a question to the product owner to clarify, for example, the user acceptance criteria, whereas AI does not do that. It takes an approximate guess in terms of understanding. So that's, I guess, the first difference.
Yeah, for sure. So for the second question, I think it really echoes the data points I was sharing, where you can see AI that has more the tendency to, like Copilot, to replace a big chunk of code and do copy paste. So less in terms of refactoring. So that means when you collaborate, when there is a collaboration between a coding assistant and a human, it's more difficult to track the change, right? If it was AI on its own and building a project, assuming it is possible, there would be no readability or maintainability issue there. But knowing that there is this collaboration with human, how do you see, especially in the TDD activity, the ability to from AI to help incrementally there?
So I would say, again, regarding the tests, they may have the readability that some average or below average developer may produce in terms of test readability. I did find issues in, for example, test naming. For example, it was calling test names in terms of the methods being tested rather than the behavior being tested. So that also affects readability. So I would say that those are some of the challenges regarding readability, and that's where it needed additional prompts to be prompted to, for example, improve test names or something like that to be more understandable.
Yeah, it's really a iterative process.
Yes, it is.
The first proposal. Yeah, for sure. So great. And when it comes to let's say the correctness of the code that is generated compared to human, which also create bugs, but based on your experience, what's the quality? Is it the quality of an average developer, or is it more proficient?
Okay. Unfortunately here, the average quality of an average developer in terms of writing tests happens to be low. Okay, perhaps not in this audience, but talking more globally across the world. So in many code bases, if we ran mutation testing, and mutation testing is the best automated mechanism to find out, to like test the tests. Are the tests protecting us against regression bugs? So there's many teams where they may be, you know, proud to have code coverage of 90% or something, but their mutation score might be 10% or 20%, indicating that their tests are not protecting them against bugs. So that issue already exists with a majority of human developers, and I found also a similar issue existing with Copilot, which we'll see later in the demo, whereby we got a lower than 100% mutation score, even in implementing a very first simple requirement. And that unfortunately also happens to be how shall I say, associated with Tesla's development, that characteristic of getting a lower mutation score. Whereas a good TDD, a good human TDD practitioner would typically be getting mutation scores of 100% or close to thereof. So I would say in that one, that there's both issues with majority of human developers and issues with Copilot.
Yeah, I definitely agree with this one. So when it comes to refactoring, and we already touched a bit about this one, where we can see the tendency to not refactor incrementally, but sometimes to even completely change the file. How efficient is it, would you say?
Mm-hmm. So again, here a similar issue that happens with many, as in the previous point, with both human developers and with AI. Basically, a lot of human developers, from what I've seen, write very mock-heavy tests and tests coupled to the design. So that means typically like testing a specific class and its methods, and then as soon as that class or methods change, like basically everything breaks. Because like every test is coupled to a specific class. And with AI solutions, the ones that essentially learn from human code bases, and that's what they also have, then they would also tend to could only produce such mock heavy. However, I've also seen, how shall I say, some different behavior. So for example, sometimes the tests produced were mock heavy, but sometimes other test doubles were used in AI. So it sort of really varied. But again, I would say that those ones, again, here that there is a challenge for both majority of human developers and AI.
Yeah, and it's not surprising because it has been trained on on human created code base and examples, so it has learned also the bad habits, not just the good one.
Yes, it could be, and the problem with that is if you use, you know, AI to write such tests, that okay, maybe you save time in writing the test, but then later for maintenance of that test, it's going to be very expensive, similar as a test written by a developer, by majority of developers inexperienced in writing tests.
Yeah, and the last question here, which is to me maybe the most important one with the first one. So we know testing and TDD is first about design. And it's critically important because if you don't come up with the right test and the right design, then there can be massive quality issues downstream. Yeah, what has been your experience so far with that?
Yeah, so as we'll see later in the practical section, I have commentary whereby I illustrated some issues in terms of how I designed, you know, the interface, the inputs and the outputs. And again, this is something where I view the needs for humans either through multiple iterations of prompts or something like that, because what happens is with tests, we are both expressing requirements and we are simultaneously designing the interface. And then if that's not fixed here, then all the other steps, we're then writing code to satisfy a bad design. So I would say again here, the design produced by AI was, in my mind, sometimes poor, sometimes okay, but it needed human prompts. It needed a human who understood good design principles, so that when AI didn't understand it well, to be able to prompt it. Now, when prompted with more guidance, yes, AI was able to improve the design. So it's like, make sure to do this in the red step and not wait, and then you can proceed forward to the next steps.
Yeah, and this is absolutely consistent with the feedbacks we have from other members in the community. So the red step is probably I would say the most challenging, right, for AI.
It is, and for humans, and that's why even when I do technical coaching, actually most of the problems is in this step. So not the code, but the tests themselves.
Yeah. So assuming Valentina, we get this right, the red phase right. If we move to the green one, how AI assistant can be helpful there and efficient.
Okay, here I did find it a lot more helpful compared to tests. So basically, after you guided to write the test well, and you look at the test, and you as a human are satisfied with it, then basically just run the build command, copy paste the compile output, the errors, into AI, and tell it, can you make the test pass? And it was able to do that. Sometimes it was in one iteration, but sometimes you paste it and it goes green for you. So sometimes it was in one pass, but sometimes in one iteration, but sometimes you would get build errors again, copy paste into AI, again copy paste into AI again. And then sometimes it took several attempts to get to pass, to get the test passing. So ultimately, yes, it was able to reach the green, essentially the green state. And I would say out of the whole TDD process, this is the lowest cognitive activity. So this is something which an average developer could also do, or below average developer could do. And this is the one out of all the TDD steps, this is also the one where I would say AI is most helpful.
Mm-hmm. And that's where we see usually the KPIs from GitHub Copilot coming in. We can write code and create features 55% faster. So one thing we've noticed, and I'm curious if you have experienced that also, is the fact that the code assistant first is not deterministic, right? So in some case it can come up with a solution, and if you ask it again, it will come with another one. And there is also the fact here that teams have a specific context, specific constraints. So they have their own coding practices, guidelines, their own convention that matters. And we haven't seen AI being able to consistently come up with the right solution for your context. So maybe it can make the test pass, but the way the implementation has been done will not follow you. Yeah, again, coding guidelines and constraints. So that means then you may have more tech debt and potentially quality issues.
Mm-hmm. That's a good point, and I think that it will link to the next step when we discuss refactoring. So in TDD, basically with the green step, all that we're exclusively interested in making the test pass. It's fine to have horrible code. So even as a human TDD practitioner, you can write any code. So whatever is the simplest or easiest, it can do it. So from that perspective, AI correct is non-deterministic, but for the green step, I would say it does not matter too much, because even for human developers in TDD, green is all about making test pass, and you can do it even with horrible code and not following any practices at all. So for that one, it's fine. But then I guess when we go to the next slide, refactoring, to follow up on your question, this is where the topic of good practices comes up. And again, here the question is, first of all, when given the task to refactor, that's a very open-ended question, to refactor to what? Since it does not have a concept of standards or guidelines, team-specific guidelines, it may have access to some, how should I say, maybe worldwide guidelines, such as methods shouldn't be too long or something like that, where you could do refactoring, but they would not be team-specific refactorings. And even in refactoring, sometimes when I would tell it, hey, can you refactor the code? It would then ask me to be more specific. It would ask me, okay, what do you want to achieve with the refactoring? And then I had to maybe choose some options. So I would say with refactoring, it can be, it may suggest ideas. Those ideas may or may not be good in any case, but if you guide it, so either if you pick from one of its ideas or you come up with your own idea and give it the guidance regarding refactoring, it generally can execute it. But it's just the idea of which refactoring to do. That's the human activity.
Yeah, it needs a really strong guidance there.
Yeah.
And that's by the way, that's the promise of Packmind, to enable the team to come up with progressively, incrementally with their standards, and then drive AI based on these standards. So the code that come up really aligns with how a developer of the team would write it.
That's a very good point. The need for having team standards, because sometimes for certain practices there are conflicting opinions. So whether to do it one way or another way, whereby the team needs to reach consensus and then essentially follow those practices.
Yeah. As I often said, there is sometimes A or B are not a bad solution, but doing sometimes A, sometimes B is a bad solution.
Exactly, it's the consistency.
Yeah. All right. So I think that's these are really insightful feedback, Valentina, and I think now it's time for the demo and see that in action.
Exactly. So this demo, the audience, feel free to access it. It's available on GitHub. So it's a TDD demo using Copilot in Java. I chose Copilot rather than ChatGPT, simply because when I did quick evaluation of both, I found Copilot in general to have better solutions compared to ChatGPT. So that's why I went here with Copilot. So this was the case study. So, and this is also the guided the prompts that I would give to Copilot. So the task was here, I want to build an eShop system, and I asked Copilot to guide me in developing this using TDD and hexagonal architecture. This was important, that I specified both of these so that it knows what process and architecture I want to use. I also gave it the user story and acceptance criteria. Now I went with giving it acceptance criteria one by one. So, one acceptance criteria that we do the TDD cycle and that I get to a level that I'm satisfied, and then I would move in terms of prompts to these next acceptance criteria. So what you see on this page, that was what I used to copy paste into Copilot, so that everything that I did with the code, that it was based on Copilot prompts. And if you go to the GitHub repository, you will see a history of all the commits. You'll see the prompts and the code that resulted. So first of all, with tests, I like to start off with poor regression bug protection, because that's something that can be converted into numbers. Other things like other tests, less or more readable, it can be a gray kind of topic, but the point is essentially using mutation score. That is something that's a more objective measure, so I like to start off with that one. And this was starting off with the first step, first test. So here we got 75% mutation coverage. So basically the root cause was that more behavior was implemented in the entity. Here, for example, the logic for incrementing the order ID was implemented, but yet that was not covered anyway by the tests. So that means the test and the code produced by Copilot, it had less than 100% mutation score. Now, this kind of thing would very rarely happen to a practice, a good TDD human practitioner, because human practitioner would essentially achieve 100% or close to 100% mutation coverage. The issue here was that we got this issue even from the first step, from the first test. So that's the first issue. So then I prompted it, hey, I copy pasted the mutation test report to Copilot to tell it, hey, you have this surviving mutant, you need to kill it. And then the problem was, yes, it did increase the mutation score, but it did it in a very strange way. So it's like I achieved one thing, but at the loss of something else. So yes, it did kill the mutant, but there were issues with writing the tests. So for example, when we're placing the order, like the whole point is, testing this like place order execute. So that act, it should have been only one act statement. And then it also did other like meaningless tests, which is just testing like ID increment and test get ID. These tests are not directly, relatable to the acceptance, for example, criteria, and it just wrote some meaningless tests just to increase the mutation score. So that's, again, so it's like both the issue with the mutation score and with its attempts. Well, it achieved the mutation score, but the tests were not well written. The other challenges that I found with Copilot, and as we can see, we're still in tests, and that is the part where I said, Copilot, we're going to have lots of challenges and we'll need prompts. We'll not need, in this here, we had the requirement that the system has unit prices for different pizza types, and the customer is selecting a pizza type and quantity and placing an order for that pizza. So the point is that the customer is selecting a pizza type and quantity. The price already exists in the system. It should not be passed in. But yet here, it's actually passing in the pizza type and the price. That should not be the case. This is poor design of the request. The request should have only pizza type, not the pizza price as well. The pizza price should have been looked up from the repository rather than passing it through the request. So this kind of thing, a human developer reading this would not have made this kind of mistake, but Copilot did. And again, even when it does make mistakes, okay, I need to prompt it until it gets the test right. So this issue was with design for the request. Then we also have design with the response. So here in terms of the response, the idea was that after placing the order, the system should show the newly generated order number and should show the order price. So that's like the output of this operation. Now, here what we can see is that the return type is order. Now, order contains more than just the order number and order price. It contains a whole heap of other fields. This is returning too much. This is not a good design. I should have returned just a simple DTO containing just the order number and the order price. So all of this, it's about, you know, how we interpret requirements and design. Again, I need, you know, you would then need to prompt it to request it to do a DTO, and then sure, okay, you can then follow your instructions when you find out that there's a problem here. Then we also had poor choice of data points. So we had some acceptance criteria about, you know, when there's a non-positive quantity, that there should be an error shown. Now, when it's non-positive, you know, you need to take into account boundary values and nominal values. So with this kind of test, you know, I would have gone, human would have gone both for 0 and let's say for -1. You know, both of those are essentially boundary kind of values, and also perhaps a nominal value like -5, and would have used a parameterized test. But Copilot didn't do any of that. It just picked one boundary value, and that's it. Like, we also have maintenance challenges. So these were on the right-hand side some existing tests when we just had the pizza and quantity. But then later, I had another follow-up acceptance criteria, which was about country-specific logic. Like, I don't know, if it's US, then there's going to be a 10% discount. And then now this caused country to be added here, and that caused a whole heap of tests to break. A human may have known to use, for example, the test builder pattern or something to avoid this kind of breakage. I mean, this is just one example of maintenance challenges. Okay, that's the end of reviewing some problems of tests. So I want to emphasize, I found all of these problems on a very, very simple exercise, like a school kind of, you know, exercise. It wasn't even a complex problem. If it was more complex, I'm sure these slides would have gone on and on. But now we jump to at least some positive parts. So writing code to make the tests pass. So when it wrote a failing test and I prompted it, when I was not satisfied with the test, I would prompt it to get the test right. Then when I was satisfied, or relatively, not fully satisfied, but at least relatively for this presentation purposes, then I asked it, can you make the test pass? And it was able to write source code, which I copy-pasted, and I ran my tests, and they passed. Sometimes they passed immediately, but sometimes there were further build errors, and I had to copy-paste again as a prompt the build errors, and then it would give me the fixes again. So I would say I was satisfied in that one. I found that it was helpful there. So this is the point how I mentioned I was copy and pasting it to it. I was not explaining the problem, but directly copy pasting the prompts. And the thing is, it was able to write the source code to solve those build errors. And yes, it did take multiple attempts. So taking these multiple attempts might be longer than a human developer, but overall, I did find it useful. Now, there were some issues. So yes, the tests were passing, but there were some issues with certain coding decisions that it made. For example, in the acceptance criteria, there was, that the system would generate an order number or the ID, and it decided to do it like directly in the order entity next ID ++. Now, the only kind of developer that might do this is maybe someone directly who finished university and has no job experience and didn't get the idea, to use application side generated IDs, like some libraries which would ensure uniqueness, or database generated IDs. A human, we would typically not do it like this directly within the entity, and this would not work correctly. Let's say when the software starts up again, and then we would have the same IDs generated again. So it's like the implementation was not so good in terms of more broader correctness. Now, when it came to refactoring, here I decided to give it a hint. I asked it, can you refactor the code? Then it asked me to be a bit more specific, like, is my goal to increase maintainability or some other goals? So I told it, okay, I want to increase maintainability. So I didn't give it the specific design, what to refactor, but just a general goal. Okay, I want higher maintainability. And let's say here it proposed to split the methods as its idea for maintainability. Now, coming back to Laurent's prior discussion about teams and stuff, this is actually a common challenge that I've had as I was coaching teams. Some teams would see this as more maintainable on the left-hand side. Some would see the one on the right-hand side as more maintainable. This was a bit one where there was some disagreement. So let's put it this way. It was able to do refactoring, but whether or not we agree with the refactoring is team dependent. This was refactoring of source code. I also tried refactoring for the test code. I prompted it to apply the test builder pattern. It applied the builder pattern, but not the test builder pattern. Then I prompted it with correction. I'm like, okay, you need to have default values in the constructor. And then it was actually able to do the test builder pattern. So that's an example again where it worked in the end for refactoring. So just to summarize, TDD with Copilot. In the red step, write a failing test, that is the one where I really view as the need for experienced, TDD practitioners, a need for the human mind. So either write it yourself, or if you're going to use Copilot, make sure like you really need to review it, give it prompts, give it guidance, like don't have expectations that are too high of AI doing this for you. But then when this is solved, and again, you can use multiple prompts, the rest, so the green step and the refactor step, I would say was relatively okay. It did need sometimes multiple attempts, but it was fine, and I did find it helpful. So I would like to say thank you. And I hope that you enjoyed this and that you try out, Copilot or ChatGPT. Well, I see many people are trying it out and see how it goes. And feel free to connect with me and follow me as well.
Yeah, thank you, Valentina. That was really amazing, and I love the example you've created. I think there was tons of value for our audience. So we have a few questions, and we can take, if you have 5 more minutes,
yes,
we can take time to answer these questions. So the first one from Jean-Pierre Lambert. Are we saying that there may be some money to be made by providing AI that would have been specifically trained by the best in-class developers? So people like you.
That's an excellent thing. So I would say that that's a very interesting idea to try out. I mean, if that is achievable, that would be like someone having access to training or coaching directly, like everyone having access to it. That would be a very novel idea to try. So that would be similar as, I guess, what Packmind is doing currently for refactorings, but then covering it for tests. To be honest, the part of writing good tests, I would find it a very challenging task to do it. But if anyone does make such a system, I would like to know about it.
So does that mean, Valentina, that we can't expect having a Valentina GPT on the marketplace, OpenAI marketplace?
Correct. And the reason why I would say it's hard is, again, even when I coach teams and, I leave behind all the recordings and all the knowledge is transferred to developers, so humans who are there, there's limited ability to translate that knowledge. So the part that they've learned, some parts they can translate, some parts they can't. And that's even with humans, where I've spent like months and months and months. So I would say that kind of task, it is theoretically interesting, but I find it very, very challenging if anyone is able to do that.
Yeah, I agree with this one. So another question from Jean Lecordier: can we trust a bad developer to use AI to compensate for their lack of competence?
Okay, can we trust? Okay, let's see. For the green step, I can trust. And let's say for the refactor step, let's say we can trust it sort of in combination with SonarQube. It might be fine for companies where there's, let's say, lack of competence, where there's issues even with human review. So I would say that AI could be useful there, to help with some refactorings and, let's say, solving issues reported by SonarQube.
Yeah. So
limited, it would have some value. It would not be the best code, but I guess it could produce okay code.
Yeah, we share a similar recommendation when you have the right guardrails in place. So SonarQube has for example, quality gate solution like Packmind for the code generated, making sure it follows the practices, good practices of the team. Then that can be a useful tool. Otherwise, it can be super dangerous. So I'm going to share a blog post from Octo, and I apologize in advance for the English audience here, but it's in French, and they've done in-depth analysis after 1 year of use of Copilot at scale. And what they've shown is a kind of S-curve. So when you give Copilot without these guidelines, right, to junior developers, there is a hit in quality. So quality really suffers, and basically you create more tech debts, and that's decrease the productivity of the whole team. Then when it comes to let's say medium or average developer in terms of seniority, that's where they've seen the biggest boost in terms of quality and productivity. And the reason it's a S-curve is when you look at the most experienced people, the gains are really incremental or marginal, I would say. So really low. So yeah, it seems like when it comes to junior, it's like giving a Formula One to someone who just got his license. Can be dangerous.
Yeah, I view it as similar to, let's say, using Stack Overflow and using the internet. So quite often, juniors other developers who've got lack of competence, they might even have been programming for 10 years. They just go for, Google search and go for the first solution, implement. They've got no idea, is it a good or bad solution? And similar thing again might be happening with AI, which happens to be trained on such quality. To find out high quality, you need someone who's really researched the topic, evaluated the various options, really knows what and where, and just simply AI is not there currently.
Yeah, so we have a final comment from Jean saying Copilot really is a love-hate relationship. When it works, it's incredible. When it does not, it's really frustrating. And I think that's a pretty good summary of what we've discussed today.
Yes.
It depends on the context, right? And who uses it. So it's not a silver bullet. It can be really great when it's in the right hands and applied in the right context. And I think that's what we are learning today.
Yeah, I must say, for example, for myself, I found it useful in the parts of sometimes writing code might become a too mechanical task. So then I found it useful that it helped minimize that time there for me, but I did need to be there for guiding it.
Yeah, cool. So any final word, Valentina, before we conclude?
I would say that all of these developments in AI is definitely, really interesting and is changing the landscape. And developers are sometimes worried about their jobs, and also engineering managers are looking, how to integrate it with their teams. So just to summarize where I see where it's useful and where not so useful, in the part of writing some code, I view it useful in the same way that Stack Overflow is useful and that Google is useful. It gives some solutions. So in there, I view AI as useful and even faster, possibly faster at finding the solution than Stack Overflow or Google. So that's the part where I view it as most useful within TDD, the green step. Then at next position, refactor step, I find that okay-ish. It may suggest refactorings, but the problem is that those refactorings may not be aligned with your team standards and guidelines. So that's where you either need, for example, if using Packmind or something else, or you need to guide it with more prompts, and then it will perform. And then, of course, using also SonarQube, and then it may perform okay. And the part where it's got worst performance and the part where I currently don't trust it is the part about writing tests. So even if I do use it to write a test, it needed a lot of prompts, and I really needed to apply my own critical analysis to guide it. And that's the one that also happens to be the highest cognitive activity, and the one where I see humans as being, how shall I say, human mind as being high value.
Yeah, and that's really, your last point is really interesting when you compare it to other feedback we've seen where many teams loves it for writing tests, but it's not a test first approach. They use the test last approach. So testing is boring, and it's an afterthought after development. And that's a use case where they see AI really useful. So it's completely different perspective, but different world.
Definitely. I mean, those teams, they may view it as like a time saver because their manager told them to achieve a certain code coverage level.
Exactly.
And it's very mundane to then write those tests retroactively. So they may use this kind of solution to write the test and can perhaps achieve a high code coverage. But the problem is that those tests may have low mutation score. They may be not understandable, not expressive of requirements, not maintainable. So even though we reduce this time when writing the test, for the meaningfulness of tests and for maintaining the tests, and maintenance cost is the biggest cost in software.
Yeah.
In that one, we actually went downwards.
Yeah, absolutely. All right. Thank you so much, Valentina. It has been a pleasure, and we've been very fortunate to have you to discuss this topic. Thanks again. And for the audience, that's the first, as I said, of a series of webinars on the topic of AI. We'll have end of June, beginning of July, also the pleasure to welcome Seb Rose, who will talk about BDD and AI. So it will be kind of phase 2 of this conversation. Thank you so much, folks. Enjoy the rest of your day. And thank you again, Valentina. Bye-bye.
Thank you. Bye.